The cosmos, an endless expanse filled with mysteries and secrets, never disappoints in providing fascinating revelations. As we delve into 2020's most exciting space discoveries, we're left to ponder one crucial question: are we really alone? From the rusting iron on our moon to the potential for life in the clouds of Venus, the universe is constantly challenging our assumptions and expanding our understanding of what's possible. Join me as we embark on a journey through the cosmos, exploring the latest discoveries and their implications for our place in the universe. Our nearest celestial neighbor, the Moon, has always held a special place in our collective imagination. It hangs in the night sky, a silent sentinel to human history, its cratered surface a testament to billions of years of cosmic bombardment. But for all its familiarity, the Moon still holds secrets. In 2020, scientists discovered rusting iron on the lunar surface. Rust? On the Moon? Rust needs oxygen, right? On Earth, rust forms with oxygen and water, but the Moon's atmosphere is too thin for rust. So how do we explain this lunar rust? The answer might lie with our own planet. Scientists believe Earth's oxygen, carried by solar wind, reaches the Moon. This solar wind acts as a cosmic delivery service. But there's another piece to this puzzle. The Moon has trace amounts of water ice in shadowed craters. This water ice, combined with solar wind oxygen, could create rust. This discovery has significant implications for our understanding of the Moon. It suggests familiar processes like oxidation might occur in unexpected ways. This highlights the interconnectedness of celestial bodies. The Earth's atmosphere, solar wind, and Moon's surface form a dynamic system. Who knows what other secrets lie hidden beneath the lunar surface? Further exploration may reveal more surprising connections between Earth and the Moon. The prevailing theory for the Moon's formation, the giant impact hypothesis, posits a cataclysmic collision between the early Earth and a Mars-sized object named Theia. This impact, billions of years ago, is believed to have ejected a massive amount of debris into orbit, which eventually coalesced to form the Moon. This theory has been remarkably successful in explaining many of the Moon's characteristics, such as its size, orbital characteristics, and its overall composition. However, recent discoveries have thrown a wrench into the works, challenging our understanding of this celestial dance. One of the most perplexing of these discoveries is the unexpectedly high metal content found in the Moon's mantle, the layer beneath its crust. This finding has left scientists scratching their heads, as the giant impact hypothesis predicts a lunar mantle, primarily composed of material from Theia, which should have a different metal content than what's been observed. The discrepancy in metal content between the Moon's mantle and the predictions of the giant impact hypothesis raises several intriguing possibilities. One possibility is that the impactor, Theia, had a surprisingly similar composition to the early Earth, which would explain the similar metal content. However, this would require a rather improbable cosmic coincidence, as celestial bodies tend to have diverse compositions reflecting their varied origins within the protoplanetary disk. Another possibility is that the impact itself, rather than the composition of the colliding bodies, played a more significant role in determining the Moon's final makeup. Perhaps the immense energy released during the impact caused a process called mantle differentiation, where heavier elements like metals sank towards the Moon's core, while lighter elements rose to the surface. This process could have concentrated metals in the Moon's mantle, even if the original material from Theia had a different metal content. Yet another possibility is that our understanding of the giant impact hypothesis itself needs some tweaking. Perhaps the impact wasn't a single cataclysmic event, but rather a series of smaller impacts over a more extended period. Multiple impacts could have delivered different materials to the growing Moon, potentially explaining the unexpected metal content in its mantle. Chapter 3: FRB's Whispers from the Cosmic Abyss. Our fascination with space is driven by a profound question: are we alone in the universe? This question has captivated humanity for centuries, fueling countless science fiction stories and inspiring generations of scientists. One such enigma is the phenomenon of fast radio bursts, or FRBs, brief, intense pulses of radio waves from distant galaxies. These cosmic winks last only a few milliseconds, but release as much energy as the Sun does in several days. Since their discovery in 2007, astronomers have been diligently working to unravel their secrets. What could generate such powerful bursts of energy in such a short time? Several theories have been proposed, each more captivating than the last. Some scientists believe FRBs result from cataclysmic events like supernovae or the merging of neutron stars. Another possibility is that FRBs are generated by magnetars, neutron stars with incredibly strong magnetic fields. The most tantalizing theory is that some FRBs could be signals from advanced extraterrestrial civilizations. Could these bursts be attempts at interstellar communication, beacons from distant galaxies signaling their presence? Chapter 4: 6 billion Earth-like planets, a galaxy teeming with possibilities. For centuries, humans have gazed up at the night sky and wondered if we're alone in the universe. It's a question that has fueled countless myths, legends, and scientific inquiries. And while we haven't found definitive proof of extraterrestrial life just yet, recent discoveries have hinted at the possibility that our galaxy, the Milky Way, could be teeming with habitable planets. In fact, astronomers now estimate that there could be as many as 6 billion Earth-like planets orbiting sun-like stars in our galaxy alone. This staggering number is based on data from the Kepler Space Telescope, a remarkable instrument that revolutionized our understanding of exoplanets, planets orbiting stars other than our Sun. Kepler spent nearly a decade observing a tiny patch of sky, meticulously monitoring the brightness of over 150,000 stars. By analyzing subtle dips in a star's brightness, Kepler could detect the presence of orbiting planets, even those much smaller than our own Jupiter. The discovery of so many potentially habitable planets has profound implications for the search for life beyond Earth. It suggests that Earth-like planets with similar sizes, compositions, and orbits to our own might not be cosmic rarities, but rather relatively common occurrences throughout the Milky Way. And if even a tiny fraction of these planets harbor life, the galaxy could be a truly vibrant and diverse place. One of the most intriguing targets in the search for extraterrestrial life is our closest planetary neighbor, Venus. Long considered a scorching hellscape with a toxic atmosphere and surface temperatures hot enough to melt lead, Venus has recently come under renewed scrutiny as a potential haven for life. While its surface is undoubtedly inhospitable, scientists have discovered tantalizing hints that life might exist in Venus's upper atmosphere, where temperatures and pressures are far more Earth-like. Chapter 5: Kepler 1649c and AU Microscopii, Unveiling the Secrets of Planetary Formation. In the vast cosmic ocean, teeming with stars and planets, there exists a world remarkably similar to our own, a world bathed in the warm glow of a distant star, a world that whispers tales of possibility and the potential for life beyond our pale blue dot. This world, known as Kepler 1649c, orbits a red dwarf star located some 300 light-years away in the constellation Cygnus. Discovered in 2020 by the Kepler Space Telescope, Kepler 1649c immediately captured the attention of astronomers worldwide. What makes this distant world so intriguing? For starters, it's remarkably similar in size to Earth, just 1.06 times larger than our home planet. But size isn't everything. Kepler 1649c also resides within its star's habitable zone, the region around a star where temperatures are just right for liquid water to exist on a planet's surface. Liquid water, as we know it, is essential for life as we understand it, and its presence on Kepler 1649c raises the tantalizing possibility that this distant world could harbor life. But Kepler 1649c isn't the only celestial object captivating astronomers' attention. In the constellation Microscopium, a mere 32 light-years away, lies a young star system known as AU Microscopii. This system, still in its infancy, provides a unique glimpse into the chaotic and dynamic processes that give birth to stars and planets. AU Microscopii is surrounded by a vast disk of gas and dust, the raw materials from which planets form. Astronomers have been eagerly observing this protoplanetary disk, hoping to catch a glimpse of planet formation in action. And in 2020, their patience was rewarded. Using the Atacama Large Millimeter Submillimeter Array, or ALMA, a powerful radio telescope located in Chile, astronomers detected signs of not one but two giant planets forming within the disk. These protoplanets, still in the early stages of their formation, are carving gaps in the disk as they accrete material and grow larger. From revelations about our own moon and space's inherent mysteries of possible alien life forms, To the implications of our climate state and the origin of water on Earth, this year has certainly delivered on captivating space discoveries. As we continue sailing through this cosmic frontier, bearing witness to the awe-inspiring enigma that is space, we can't help but wonder whether we are indeed alone in this unimaginably vast universe.